Greetings everyone, this is Mr. Muller. In this podcast I'm going to be doing a little lecture on types of intermolecular forces. So there's three types of intermolecular forces. The name says it all. It's forces between molecules. Interpersonal relationships are describing relations between persons. Intermolecular forces are describing the forces between molecules. So this is going to be for molecules only. So when I mean molecules, I'm talking about two or more covalently bonded atoms. So the first type of intermolecular force we're going to talk about, we've already had a little bit of exposure to it. It's going to be hydrogen bonding. Is the first intermolecular force. And this is going to be a very special type of intermolecular force that occurs between molecules that have hydrogen, and that hydrogen is directly bonded to nitrogen, oxygen, or fluorine. Okay, nitrogen, oxygen, or fluorine. So when I look at these different elements, I'm thinking hydrogen, okay, is a pretty low electronegativity for a nonmetal. For a nonmetal, it's pretty low. And for these guys here, they have very, very high electronegativities, and they're very small. Okay, they're very small. So when I have and hydrogen is actually very small too. So when I have two small atoms getting together, and there's this huge difference in electronegativity, you spread that huge electronegativity difference over a short distance, and what you get is a super covalent bond, or a super high. So my change in electronegativity difference is huge between these, and you're going to get a very super polar bond. So there's going to be a very strong attraction between the partial charges in atoms that have hydrogen directly bonded to nitrogen, hydrogen directly bonded to oxygen, or hydrogen directly bonded to fluorine. So we're going to have a strong partial charge attraction, and so what that might look like, I'm just going to use our favorite example of water. So here's a little simulation of some water molecules bouncing around. And you may say, well, why is water a liquid at room temperature? Why doesn't it just turn into a gas? Why don't those molecules that are moving so fast and in random directions break free? And some of them can break free if they have enough kinetic energy, but most get held back by the other water molecules. Something is keeping them attracted to the other molecules, keeping them condensed in the liquid phase. So when I look at water in the solid phase, if I've got it chilly enough, you can really see the way the molecules kind of stick together. And so and you can even look at look at how they're sticking together. You've got the oxygen of one molecule sticking to the hydrogen of another. There's these attractions formed. Now in the solid phase, those attractions are obviously a little bit more rigid. In the liquid phase, there's still those interactions. They're just not taking place for as long. They're getting broken quickly, but they are kind of keeping all those other water molecules in check as those hydrogen bonds are acting. So what does that look like kind of zoomed in? What might that look like kind of zoomed in? So let's say I have my little water molecule here. And remember, my oxygen is partially negative. My hydrogen is partially positive. Remember, you've got these two bond dipoles going towards oxygen, forming my molecular dipole, which is going to be in that direction towards oxygen. So all my electrons are kind of hanging out over here. If I want to look at my electrons are really hanging out over here, and not so much time by hydrogen. So what happens is if the hydrogen atom of another water molecule is close by, it's also partially positive charge, partial negative, partial positive. And what happens is there's a attraction, temporary attraction between the hydrogen of one and the oxygen of another. And this water molecule here could also be interacting with another one. And you've got all these different interactions possible where the partially positive hydrogen and the partially negative oxygen are going to be opposite charges attract. They're going to be attracted to each other. And so that's going to be a strong force of attraction. Another type of condensing or intermolecular force that we're going to be looking at is going to be a type of hydrogen bonding is actually a type of this intermolecular force. So I'm going to draw a little arrow on here showing, okay, I'll do a different color here. I'm going to draw a little arrow showing that hydrogen bonding is actually just a type of, okay, it's just going to be a type of this. And that's called a dipole-dipole force. Okay, so what is a dipole-dipole force? A dipole-dipole force is a force of attraction that occurs between all polar molecules. All polar molecules. Between all polar molecules. So when I look at my hydrogen bonding occurs between molecules that are hydrogen bonded to one of those three things. This is, of the three that we're going to talk about today, this is the strongest for the three different types. So I'm going to go ahead and put on here, this is the strongest. So dipole-dipole force is a medium strength intermolecular force, and it's going to occur between all polar molecules. So when I'm looking at a polar molecule like HCl, hydrochloric acid, so this is a medium strength partial charge attraction force. Things that exert dipole-dipole forces are usually going to be liquids. That are going to have this type of force, and there's still going to be a pretty high difference in electronegativity between atoms involved, but not as high as hydrogen bonding. So we've got example for HCl. So here's HCl. I could draw a little Lewis dot diagram, and if I look at the dipole here, chlorine is way more electronegative than hydrogen. So as a whole, this thing has uneven sharing of electrons. You know, my electrons are going to be way more likely to be spending time over here by Cl than hydrogen. And so chlorine is going to get a partial negative charge, hydrogen is going to get a partial positive. And then those molecules are going to be able to find other HCl molecules. And there's going to be a force of attraction between those oppositely charged ends or regions of the atom. So when two molecules come in contact with each other, they're going to kind of hold hands for a little bit as they form that force of attraction before they break, and that's going to keep them usually condensed as a liquid. So this is going to be a type of force that exists between all polar molecules, and the hydrogen bonding, the force between the H and the O, that was just a type of dipole-dipole force, and it's called dipole-dipole because I've got the dipole of one atom and the dipole of the other, those partial charges attracting to each other. So that's why it's called dipole-dipole force, and that's going to be for all polar molecules. So if you have a molecule that's polar, it has dipole-dipole forces acting between between molecules of that compound, and then if that polar molecule has hydrogen bonded to one of those three, then it's a special type of dipole-dipole force called hydrogen bonding. In a subsequent video, I'm going to talk about dispersion forces, which is the third type of force, and that's going to be, that's all. So I hope that this was helpful, and have a wonderful day.